most of what we're doing. For what values of R is the sequence R to the n convergent? So you're thinking about R as being some fixed number. So the way it's written, it might not seem familiar, so let me rewrite it. I'm going to replace R by the letter A and n by x. What kind of function is this? A to the x. And it's an exponential function. So this reminds me of an exponential function, which we know the limits for exponential functions. All right, if I take the limit as x goes to infinity of a to the x, it's going to be, it depends on the value of a. So if a is greater than 1, you're going to get infinity for that limit. If it's between 0 and 1, you're going to get 0. So if this is kind of a little bit too complicated, think of an example. If a is 2, you're taking 2 to the x, which is it grows up really fast, right? As x goes to infinity, I'm getting a large number, so I'm getting infinity for that limit. Pick a number between 0 and 1, like a half. What happens when you raise 1/2 to powers? 1/2 squared is 1/4, 1/2 cubed is 1/8. The numbers are getting smaller, right? So that's why you're getting 0 for this limit, okay? So we know what happens. So remember, A is essentially replacing R, just so we could recognize it's an exponential function. So if R is greater than 1, is my sequence going to converge or diverge? Sorry. If R and A are the same thing, okay? So if R is greater than 1, which means I'm also looking at A is greater than 1, what was my limit? Infinity. So does that mean my sequence converges or diverges? It diverges, okay? The sequence diverges. Yeah. Okay. So we basically know what happens for very specific values of R. What I'm saying is that if R is between 0 and 1, R and A are the same thing, remember, then the sequence converges. If R is bigger than 1, then it's going to diverge. But this isn't all of my possibilities, right? For R. What numbers have I not counted?
Negatives.
Negatives. What else haven't I counted?
Decimal.
These inequalities are less than, right? 1 and 0, right? Those are the three things I haven't included. 0, 1, and negative numbers. So let's check those out. So we're just going to plug in 0 and 1. They're fixed numbers, so I can just plug them in and see what happens to my sequence. So let's start by plugging in 1. If R equals 1, then I'm looking at the limit of 1 to the n. What's 1 to the n? It's just 1. And what's the limit of 1? 1. So is this sequence going to converge or diverge? Converge. Converges when R is 1. Okay? So we know it converges here, converges there, diverges diverges there. Okay, so we took care of 1. Now let's plug in 0 and see what happens. Let's plug in if r equals 0. And I'm looking at the limit as n goes to infinity of 0 to the n. What's 0 to the n? 0. What's the limit of 0? 0, because it's just a constant. So what's my answer? Converge, diverge? Converges. Okay. So now I know I've addressed 1, I've addressed 0, so all I've got left to address is negative numbers. Okay. All right, so let's see what happens if I plug in a negative number. So I'm going to break it up. We had the positive numbers, we broke up between 0 and 1, and then bigger than 1. Same kind of thing here. I'm going to break it up between -1 and 0. What's the absolute value of r going to be between, if r is between -1 and 0?
This is when I do the flipping.
Mm-hmm. Yeah, because it's negative. You're multiplying by -1. So you're going to flip it 0 to 1. If I take any number between -1 and 0, take its absolute value, like -1/2, the absolute value is +1/2. Okay? Remember, absolute value, all you're doing is you're forcing your negative number to become positive. Okay? And remember, now we have an alternating sequence because it's flipping signs, negative to positive, negative to positive. So what did we do when we had flipping signs before on the previous example? When we did -1 to the n over n, I think that was the example. Yeah, -1 to the n over n.
Take the absolute value.
You take the absolute value. Remember, that's a way of dealing with negative signs is I take the absolute value. So I'm looking at the limit of r to the n. This is the same thing as the limit of the absolute value of r to the n. So now what you've done, r is negative, right? So when I take the absolute value, this is positive. And you said that the absolute value of r is between 0 and 1. This is just another exponential function. My base is between 0 to 1, so look back up at our rules. If I'm between 0 and 1, the limit's 0. So that tells me down here, because I have this condition that tells me the absolute value of r is between 0 and 1, this limit is 0. So what am I getting? Converging or diverging? Converging. Okay, so it converges in this range, it's going to converge. Okay. The last thing, what about negative numbers smaller than -1, less than or equal to? We've actually done equal to -1. That was that example, -1 to the n. So if r equals -1, then our sequence is -1 to the n, which we already saw diverges. If r is less than -1, the sequence r to the n is going to diverge. And the way you can see that is maybe through graphing these. So pick a value of r less than -1, so maybe like -2. And graph it, and you'll see what happens if I plug in 1 I'm getting negative 2. 2, what do I get if I plug in 2? 4. If you plug in 3, you'll get negative 8. If you plug in 4, you're going to get positive 16. So what's happening is they're spreading further apart, which means the limit doesn't exist. They got to come together, right? I got to converge to a number. My numbers can't get further and further apart. Okay. All right, so I know that was a lot. Let's sum up what we've learned about sequences with these exponentials in them. In summation, r to the n is convergent if r is between -1, not including -1, but including 1, and divergent for all other values. And if you want to know what the limit is in the cases where it converges, I'll write that for you as well. The limit is 0 between -1 and 1, but if it's equal to 1, the limit was 1.